Hey everybody, welcome back to Lean on Success, where process improvement is self-improvement. My name is Ben. I'm a Lean Six Sigma Master Black Belt, and on this episode, we are completing our white belt saga. This is white belt parts dry, right? It's a European 3 because dry is 3 for German. And it's really fitting that we're using dry as our word for today because a lot of you see Six Sigma as being pretty dry. Well, hopefully, I'm going to dispel that for you and make this topic interesting and exciting as possible. So, without further ado, let's jump right in. Okay, so let's start with the basic definition. What is Six Sigma? Well, first, we need to understand this little Greek sign here. This little symbol is actually the Greek letter sigma. And in mathematical notations, it stands for the standard deviation. Now, if it sounds like I'm talking Greek to you, it's because this is literal Greek, okay? So don't feel bad, all right? Now, what you need to understand for this introduction is standard deviation is really a mathematical measurement of how much variation there is in your process. And process variation is very bad from a Six Sigma standpoint. It's just like Muda on the lean side, variation is the enemy on the Six Sigma side. So let's give you a graphical representation of this, okay? Let's say that you have a particular set of data. You have a nice little pretty symmetrical bell curve, right? Some of you may be familiar with the bell curve and what it means or doesn't mean. In a future video, we're actually going to unpack this a little bit and help you to understand mathematically what this means as well as practically how it can be applied in real life situations. But we have this particular process data, and this bell curve represents output from that process. And what we would say, looking at this data, is that it has a very low standard deviation. Okay, it has a narrow variation. It's a very skinny graph, and it's a very tall graph, kind of like C-3PO from Star Wars. Okay, so when you see data that's tall and skinny like this is the ideal from a process variation standpoint. It's like C-3PO. Now let's consider a different set of data. Okay, now this one is a little bit wider, more spread out, doesn't sit as tall. And when you see this type of data, what it basically means is that generally speaking, there's a high standard deviation. Okay, it has a very wide variation. It's kind of short and stubby and fat, kind of like Jabba the Hutt. Okay, so if you notice, this white line here actually represents the average for both of these sets of data. So you can see that even though the average of both of these sets of data is exactly the same, they look very different because of the amount of standard deviation that exists in each of those sets of data. So let's break that down a little bit and talk about Six Sigma as a measurement. Let's say you have a particular process. We're going to use our tall, skinny graph from the previous slide, and you have some type of specification limit. Now, basically, all this means is the customer may have a particular requirement, and all of the output from that data has to fit within this particular requirement. To state it very simply, imagine that you're trying to fit this particular set of data through a door, and the average of the data set represents one side of the door, and your specification limit, which is what the customer requirements are the other side of the door. When we talk about something having Six Sigma quality, it basically means that I can fit Six Sigma through that door, right? In other words, my specification limit is 6 standard deviations away from the average of the process. That's what we would consider to be a process operating at a quality level of Six Sigma. The higher the Sigma level, or the more C-3POs that you can fit through the door, the better the process is operating from a quality standpoint, because that means that most or all of the data is fitting inside of what the customer requires. All right, now let's consider the other data set from the previous slide, the short stumpy one. As you can see, I can only fit 2 Jabas through that same door. So we would say that that process is operating at a quality level of 2 sigma because only 2 Jabas can fit through the door. So now you can see, again, 2 processes that have the exact same average, but because of their standard deviations, they have very different results and different perspectives in terms of how well they fit within the customer requirement. All right, so let's talk a little bit about the history of Six Sigma. It starts with a company called Motorola in the 80s. And the Motorola engineers recognized that there are all these different tools that have been around for decades and sometimes over 100 years that are used to measure quality, to do root cause analysis, help us perform our jobs as quality engineers. So, what they decided to do was to organize all of these different tools and methodologies and apply some project management discipline to it. We're going to take all these different tools and put some rigor and structure behind it. When we're working projects, they're going to work in 4 phases. That's the measure phase, the analyze phase, the improve phase, and the control phase. We'll talk about those a little bit more in just a second. So they basically took this hodgepodge of tools, created an organized toolkit for it, and put project management parameters around it. And that's how the Six Sigma methodology was born. Now, later on in the 90s, the legendary Jack Welch, as he started to implement Six Sigma in his company, recognized that there needed to be an additional stage at the beginning of the project around definition. We need to make sure that we are clearly defining what the problems are that we're going to focus on the project. This led to the overarching Six Sigma methodology that we know today, and it is called DMAIC. You define the business opportunity, you measure the process in its current state, you analyze the causes of waste or variation, you improve the process by mitigating all of those causes you identified in the analyze phase, and then you make sure that you are controlling the improvements in order to sustain the results. And this is the DMAIC or DMAIC process for Six Sigma projects. Now let's discuss how DMAIC and Six Sigma methodology is used within the framework of a problem-solving strategy. We're going to start with the auto manufacturing process. That's kind of been the theme of the last 2 parts of our white belt training. So you have this auto manufacturing process. Now, a process is really just a repeatable set of steps that transfers input into output. That's all a process is. So in the auto manufacturing process, you're going to have all of these different parts. You got the electronics, the engine, the transmission, sheet metal, interior, wheels, and tires. So all of these things on the left side, we will call X's, right? These are X's. These are inputs into your process. So you're going to take all of these inputs, you're going to run them through this process, and at the end, you're going to have a fully assembled vehicle. This is the output of the process. We call that the Y. So a process takes in X's, which are inputs, and transform those X's into a Y, which is your output. So when we are describing the relationship in this process, we say that the Y is a function of the X's. So mathematically, we could display it as this. Y is a function of the X's. And this mathematical notation is the foundation for analysis done in Six Sigma projects. That is it. You are officially white belted. Give yourself a round of applause, pat on the back, however you celebrate in wherever part of the world you are. Thank you so much for taking this journey with me. If you like this video, please hit that like button and subscribe to the channel. If you hated this video, please press the unlike button and still subscribe to the channel. If you could care less, please hit the like or unlike button, subscribe to the channel, and share this content with your family, friends, and people that you hate. Make sure that you reach out to them too. Thank you so much.